The rumble of engines and the smell of gasoline are fading into the past. A new era of automotive care is dawning with the rise of electric vehicles. Gone are the days of greasy oil changes and exhaust fumes. EVs bring a paradigm shift, demanding a different approach to maintenance. Understanding these differences is key to embracing the electric future. For decades, car maintenance meant dealing with complex internal combustion engines. Oil changes, tune-ups, and emissions checks were routine. EVs, however, operate with far fewer moving parts. This simplicity translates into a significant reduction in maintenance needs. The future of car maintenance lies in mastering the intricacies of batteries, software, and electrical systems. This shift requires new skills and knowledge from both mechanics and car owners. As we delve deeper into the world of EV maintenance, you'll be well equipped to navigate this exciting new frontier. One of the most significant advantages of EVs over traditional vehicles is their mechanical simplicity. Internal combustion engines, with their intricate network of pistons, valves, and belts, are notorious for requiring frequent and often costly maintenance. EVs, on the other hand, operate on a much simpler principle. An electric motor, powered by a battery, provides the driving force. This simplicity translates directly into reduced maintenance requirements. Fewer moving parts mean fewer things to break, wear down, or require replacement. Oil changes, a staple of traditional car maintenance, become a thing of the past. There are no spark plugs to replace, no timing belts to adjust, and no exhaust systems to worry about. This streamlined design not only saves time and money, but also contributes to a more environmentally friendly mode of transportation. The battery is the heart of an electric vehicle, and its health is paramount to the car's performance and lifespan. Unlike traditional cars, where the engine is the focal point, EV maintenance revolves around ensuring the battery's optimal condition. Battery care involves understanding factors that influence its performance. Temperature extremes, both hot and cold, can impact battery life. High-speed driving and frequent rapid charging can also contribute to faster degradation. Regularly monitoring your EV's battery management system is crucial. The BMS provides vital information about the battery's state of charge, temperature, and overall health. By adopting battery-conscious driving habits and adhering to the manufacturer's recommended charging practices, you can significantly extend the life of your EV's battery and ensure optimal performance for years to come. In the world of electric vehicles, software plays a pivotal role that extends far beyond entertainment and navigation. EVs are essentially computers on wheels, relying heavily on software for optimal performance, efficiency, and safety. Regular software updates are crucial for keeping your EV running smoothly. These updates, often delivered wirelessly over the internet, introduce performance enhancements, bug fixes, and even new features. Manufacturers use software updates to fine-tune the EV's powertrain, improving efficiency and range. Updates can also enhance safety features, such as lane keeping assist and automatic emergency braking, by refining the algorithms that govern these systems. Keeping your EV's software up to date is essential for accessing the latest advancements and ensuring that your vehicle operates at its best. Just like you wouldn't hesitate to update your smartphone or computer, treating software updates in your EV with the same importance is crucial. Section 5. The EV Toolkit, specialized equipment for a new breed. The shift to electric vehicles brings with it a need for specialized tools and techniques in the automotive repair industry. Traditional mechanics' toolboxes filled with wrenches and screwdrivers are no longer sufficient to handle the complexities of EVs. Working with high-voltage electrical systems demands a different set of skills and equipment. Insulated gloves and tools are crucial for safely handling electrical components. Specialized diagnostic equipment is needed to communicate with the EV's computer system, read error codes, and monitor battery health. Furthermore, the lightweight materials used in EV construction, such as aluminum and composites, require different repair methods compared to traditional steel car bodies. Mechanics need to be trained in the proper handling and repair of these materials to avoid causing further damage. As the EV market grows, the demand for EV-trained technicians will continue to rise. The automotive industry is adapting to this shift by offering specialized training programs and certifications to equip mechanics with the skills and knowledge needed to service these technologically advanced vehicles. The price of innovation, comparing costs over time. Electric vehicles often come with a higher upfront cost compared to their gasoline-powered counterparts. However, when considering the total cost of ownership over time, EVs can offer significant savings, particularly in terms of maintenance. While the initial purchase price of an EV might be higher, several factors contribute to potential long-term savings. As mentioned earlier, EVs have far fewer moving parts, resulting in reduced maintenance needs and costs. Oil changes, transmission flushes, and other routine maintenance tasks associated with traditional cars are eliminated. Furthermore, the cost of electricity is generally lower than gasoline, leading to significant savings on fueling costs over the vehicle's life. Additionally, some governments offer tax incentives and rebates for purchasing EVs, further offsetting the initial cost. While the cost of replacing an EV battery can be significant, battery technology is constantly improving, leading to longer lifespans and decreasing replacement costs. As the EV market matures and economies of scale come into play, the price gap between EVs and traditional cars is expected to narrow even further. Section 7. The Green Factor: Environmental Impact of EVs. Electric vehicles are widely regarded as a key component of a greener and more sustainable transportation future. By eliminating tailpipe emissions, EVs contribute to cleaner air quality, especially in urban areas often plagued by smog and pollution. The environmental benefits of EVs extend beyond reduced emissions. They operate much quieter than traditional vehicles, reducing noise pollution in cities and residential areas. Furthermore, as the electricity grid transitions to renewable sources like solar and wind power, the environmental footprint of EV charging diminishes further. However, it's important to acknowledge that the environmental impact of EVs is not entirely without challenges. The production of EV batteries requires significant amounts of energy and raw materials, which can have environmental implications. Addressing these concerns involves responsible sourcing of materials, developing more efficient battery production processes, and establishing robust recycling programs to ensure the safe and sustainable disposal of EV batteries at the end of their life cycle. Section 8. The EV workforce: a growing demand for skilled technicians. The rapid adoption of electric vehicles is creating a surge in demand for skilled technicians who can diagnose, maintain, and repair these technologically advanced vehicles. Traditional mechanics with expertise in internal combustion engines require specialized training to transition to the world of EVs. The skills required to work on EVs differ significantly from those needed for traditional cars. EV technicians need a strong understanding of high-voltage electrical systems, battery technology, and software diagnostics. They must be comfortable working with specialized tools and equipment designed for handling high-voltage components safely. To meet this growing demand, vocational schools, community colleges, and automakers are offering specialized training programs and certifications for EV technicians. These programs cover a wide range of topics, from basic electrical theory to advanced diagnostics and repair procedures. As the EV market continues to expand, the demand for skilled technicians will only intensify, creating new job opportunities and transforming the automotive workforce. Section 9. Driving into the future: EVs and the smart city. Electric vehicles are poised to play a transformative role in the development of smart cities, contributing to a more sustainable, efficient, and interconnected urban environment. As cities strive to reduce their carbon footprint and improve the quality of life for residents, EVs emerge as a key component of this vision. The integration of EVs into smart cities extends beyond simply replacing gasoline-powered cars. EVs can serve as mobile energy storage units, feeding electricity back into the grid during peak demand periods, a concept known as vehicle-to-grid (V2G) technology. This capability can enhance grid stability, reduce reliance on fossil fuels, and lower energy costs. Furthermore, EVs can communicate with smart city infrastructure, receiving real-time traffic updates, parking availability information, and even optimized charging recommendations. This interconnectedness can improve traffic flow, reduce congestion, and enhance the overall driving experience. As the EV revolution gains momentum, the lines between transportation and technology will continue to blur, paving the way for a future where EVs are seamlessly integrated into the fabric of our smart cities.